Hello guys, so I welcome you to the lecture 5 of the introductory course on C++. So in this course we will learn about uh, bitwise operators, right? We will, before learning bitwise operator we must know that bitwise operators are binary operators, okay? We do need two variables to operate with bitwise operators, right? Only in the case of bitwise not operator, we will need a single variable to work. Okay, so let's start from the bitwise OR. Okay, so the first bitwise operator is bitwise OR. Okay, it is represented by this symbol. Okay, in case you don't know how to use this symbol, I'll tell you while we'll be writing the program. Okay, so let's see how what is the definition of bitwise OR. So bitwise OR says that if the two bits have if one of the two bits have the value 1, then the result will be 1 only, and if both the bits have value 0, then only we'll get 0. Okay, let me tell you how. Okay, so these are the rules of bitwise OR. Okay, so 0 bitwise OR 0 will give us 0. Only in this case we get 0. Okay, yeah, so 0 or 1 will give us 1. Okay, third, 1 or 1 will give us 1. Okay, and the last rule, which is 1 or 0 will give us 1 as well. Okay, now yeah, so let's see some examples. Okay, so the example would be, let's say we take int a is equals to 2. Okay, let's say we take another integer int b is equals to 3. Okay, we declare these two integers within the C++ program. Now if we try to find a bitwise or b, okay, what value do we get? Okay, so I already told you about the binary representations, how to find the binary representation of the number. So I'll simply write the binary representation. Okay, so the 2 has the binary representation 1 0. Okay, and 3 has the binary representation 1 1. Okay, in case you don't know the binary representation of a number, you can watch the lecture ahead. Okay, so yeah, so if we try to find the bitwise OR of these operators, let's just write the binary representation one below the other. Okay, so this is the binary representation of a, this is the binary representation of b. Now if we try to find a bitwise or b, okay, what we get? Okay, so in the first place of a we have 0, but in the ones place of b we have 1. Okay, so 0 or 1, according to the rule we get 1. Okay, so this will give us 1, and in the tens place of a we have 1, in the tens place of b we have 1. Okay, so 1 or 1, let's see the rule. Okay, it gives us 1, so we'll get 1 1 as the binary representation. So what number is this 1 1? Okay, so 1 1. Okay, let's try to find the number, let's try to extract the number out of it. So this is the first place, so it represents 2 raised to power 0. Okay, and since it is set, so we'll consider this value. Okay, so this is also a set bit, so this is 2 raised to power 1. Okay, so the number will be 2 raised to power 1 plus 2 raised to power 0, which is 2 plus 1, which is 3. Okay, so the bitwise OR of a and b will be 11, will be 3. Okay, so yeah, so if we try to find a or b, we'll get the value 3. Okay, let's get back to the Visual Studio Code and let's see how it is working. So int a, whether it is working or not. Okay, so int a is equals to 2. Let's say we take int a is equals to 2. Okay, let's say we take another variable b is equals to 3. Let's say we try to print the value of a or b. Okay, let's see what value do we get. Okay, a or b. Okay, let's see, let's execute this. Okay, okay, let's execute this. So the value that we get is 3. Okay, so why is this? Because I already told you that when we try to find the bitwise OR, it will work this way. Okay, now yeah, so this was all about bitwise OR. One more thing that you can do is that instead of just printing directly, you can also store this value within some variable, let's say in c. Okay, 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 like this way, and now you can print this variable c. Okay, so it will give the same thing, 3. Okay, so yeah, let me take you to the screen again. Now let's look at the second uh, bitwise operator. So let me add the page. Okay, so the second bitwise operator will be bitwise and. Okay, bitwise and operator. Okay, this is represented by symbol this. Okay, this is represented by this symbol. Okay, now how bitwise and works. Okay, let me tell you the rule. Okay, so if there are two bits this way, if the both value of both bits, if the value of one, any of the one bit is 0, then the result will be 0, otherwise the result will be 1. What I'm trying to tell you guys is that 0 bitwise and 1 will give us 0 because we got 1 0 here. Okay, 0 and 0 will also give us 0. Okay, 1 and 0 will also give us 0. Only in the case of 1 and 1 we get 1 as the output. Okay, this is 0. Okay, only in the case of 1 and 1 we get 1. Okay, so yeah, these were the rules of bitwise and operator. Okay, bitwise and operator. So this is just opposite of bitwise or. Okay, bitwise or, in bitwise or, even if we get one, one a single one, we will get the output as 1. Here even if we get a single 0, we'll get the output as 0, right, in every case. So here also we get 1 0. Even if there are two zeros, we'll get the output as 0 only. Even if we receive, we find that there is 1 0, we'll get the output as 0. Okay, now let's see by taking an example. Okay, so example would be, let's take the same example. Okay, int a is equals to 2. Let's say we declare another variable b which has the value 3. Okay, now if we try to find out the bitwise and, so 2 can be represented in binary representation this way, in this way. B can be represented in this way. Okay, now if we try to find a bitwise and b, what do we get? Okay, so in the ones place of a we have 0, and in the ones place of b we have 1. So 0 and 1, according to rule, 0 and 1 gives us 0 only. I already told you that even if we get one single 0, then the output will be 0. Okay, so we get 0 in the first place. For the tens place we have 1 here and we have 1 here. Okay, you'll use the same technique even if there are multiple bits. Okay, I'm only having bits till tens places, so I take it as 1. Okay, so 1 and 1. Okay, 1 and bitwise and will give us 1 only. So this is the bitwise and of a and b, bitwise binary representation of a and b. Okay, so upon doing a and b, the number we get, let's extract the number out of it. So this is the binary representation. So this would have been 2 raised to power 0, but since it is not set, so we won't consider this value. This is 2 raised to power 1, and it is, since it is set, so we'll consider this. So 2 raised to power 1 will be 2 only. So the bitwise end of a and b will be 2. Okay, let's see by executing the program. Okay, so if we try to change this to end, bitwise end. Okay, and if we try to print this now, okay, see, let's try to print this. We get the output as 2, right? Yeah, so we got the output as 2. So this implies that we are absolutely correct till now. Now moving on to the third operator. Okay, which is going to be bitwise not operator. Okay, bitwise not operator. Okay, this will be the third operator. So what is bitwise not operator? Okay, so a bitwise not operator is represented by this symbol. Okay, this symbol. So but what bitwise not does is that, let's say we take a number int a is equals to 5. Okay, the binary representation of 5 looks like this. Okay, 1 0 and 1. Okay, so this is the binary representation of 5. Okay, now if we take not of it, it gives us, the bits are flipped. The bits which were 1 initially becomes 0, and the bits which were 0 initially becomes 1. So the bitwise not of a, which is 5, okay, gives us 0 1 0. Okay, so let's extract the number out of it. This is not set, so we won't consider this. This is set, so we'll consider this. This is 2 raised to power 1, and this is also not set, so we won't consider this. So the number is 2. Okay, so the number that we get upon doing bitwise not of 5 is 2. Okay, so you can get to know about it if you try to program if you try to use this bitwise not in the programs. Okay, so let's say int a is equals to 5, and let's try to, okay, I forgot one thing. I forgot to tell one thing. Okay, so we do not have only three uh, binary places. Okay, we have 32. I told you that in 32 bit representation we have 32 places, right? Okay, so we won't get two actually. So what happens is that we have 32 places, okay, and only these first three places are filled and rest of the places are zero. Okay, till the 32nd place. Let's say this is the 32nd place. Okay, till this place it is every bit is zero. Okay, now if we try to find not of this number, okay, all these places becomes one. Okay, where initially which were filled by zero. Okay, and the places which were one initially become zero. Okay, and this also becomes one. So this number will be pretty large. Okay, let's take in this will be a this since this is a signed integer, the value lie in between 2 raised to power minus 2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so yeah, this value of bitwise not of 5, okay, lies in between this range. Since I already told, I already know the value. The value is going to be minus 6 as per uh, you know that's what I think. Okay, let's try to print this. Okay, so if we try to print not a, okay, let's see what we get. Okay, yeah, so we get minus 6 as the output. So why is this? This is going to be a pretty complex thing for a beginner. So let me tell you by taking example of an unsigned integer. Okay, so unsigned integer we denote it this way. Okay, unsigned int a x, let's say we take it as 1. Okay, so unsigned integer lies in between 0 to 2 raised to power 32 minus 1. Okay, 2 raised to power 32 minus 1. Now you know the binary representation of 1 looks like this. So only the first bit is going to be set, and the rest of all the bits in the binary representation are going to be 0. Okay, till the 32 places, right? Till the 32 places. So only the first bit is going to be 1. So if we try to if we try to find the not of it, so all the zeros becomes 1. Okay, all the zeros becomes 1, and this becomes 0. Okay, this place becomes 0. So let me take you to another page. Okay, so yeah, so it looks something like this: 1 1 1 1 1 1 1 1, 32 ones, and then finally we'll get 0 in the first place. Okay, so this is a pretty large value. Okay, so yeah, so this value that we get is 2 raised to power 32 minus 1 minus 1. Okay, so this is the value. Okay, or we can write it as 2 raised to power 32 minus 2. Okay, since only the first bit is not set. Okay, we can, a 32 bit number, a 32 bit representation of a number which has all the 32 bits set. Okay, all the 32 bits as 1. I've already, let's assume that all the bits are set. So this can be represented as 2 raised to power 32 minus 1. Okay, and since the first bit of the number of not of 1 is not set, so we reduce 1. Okay, this is how we write it this way. Okay, 2 raised to power 32 minus 2. Let me tell you this again. Okay, so let me take you to page 3. Okay, so if a number is there whose all the 32 bits are set, okay, all the 32 bits are set, let's say these are the 32 bits and all of them are set. Okay, we can write that number this way: 2 raised to power 32 minus 1. Okay, this is the largest signed number in the 32 bit representation. Okay, now if we see the not of x, okay, we already considered the value of x as 1, right? So if we try to find the not of x, we'll get all the bits signed except the first. Okay, except the first, which will be 0. Okay, so all the 31 bits to the left signed, and the 30, the rightmost bit will be 0, right? So all the 32 bits if signed, this represents the number 2 raised to power 32 minus 1, and since the first bit is not signed and it has the value 2 raised to power 0, which is 1 only, right? So we will reduce 1 from this and we'll get the value that this binary representation represents. Okay, so this will become 2 raised to power 32 minus 1 minus 1. Okay, so this becomes 2 raised to power 32 minus 2. Okay, let's try to find this number on the Visual Studio Code itself. Okay, so let's say we have an unsigned integer. Unsigned integer is usually positive. Okay, that's why I told you the range in between 0 to 2 raised to power 32 minus 1. Okay, so unsigned int x is equals to, let's say, 1. Okay, now let's try to print not of x. Okay, so we'll receive a large positive number. Let's see what number do we receive. So we receive this number, right? So this is the number that we'll get after doing not of x, which is 1. Okay, and it lies in the range 0 to 2 raised to power 32 minus 1. Okay, this we have to remember. Okay, so now let's get back to the screen. Okay, now let's talk about bitwise XOR operator. Okay, let's add a new page. Okay, so bitwise XOR operator. Okay, what is bitwise XOR? It is represented by this sign. Okay, bitwise XOR is represented by this sign. Okay, so what are the rules for bitwise XOR? So bitwise XOR says that only if both the bits are same, let's say 1 XOR 1. Okay, bitwise XOR 1. So this gives 1. Okay, 0 XOR 0. Since both the bits are 0 or same, okay, both the bits are same, it will give us 1. And in the rest of the cases, 1 XOR 0 or 0 XOR 1, it will give us 0. Okay, let's see. Let's look at the examples. Okay, so let's take a few examples. Okay, so let's say we have int a is equals to 2. Let's take the initial example only. B is equals to 3. Okay, now we try to find a is or b. What do we get? Okay, so a can be represented in binary form as 1 0. B can be represented in binary form as 1 1. Okay, now if we try to find bitwise XOR of a and b, what do we get? Okay, in the ones place we have 0 XOR 1. Okay, so according to rule, 0 XOR 1, if they are different, if both the bits are different, we'll get 0. Okay, so here we get 0, this is 0. In the tens place we have both the bits as set. Okay, so 1 XOR 1 will give us 1 only, because both are same. Okay, if both the bits are same, either they are 0 or they are 1, doesn't matter, the answer will be 1. And if any of the one bit is different from the other, then the output will be 0. Okay, so 1 1 give us 1 only. So this is the bitwise XOR of a and b. Okay, so the bitwise XOR of a and b, let's extract the number out of it. Okay, so this is the binary representation, right? 1 0. So the number will be, this would have been 2 raised to power 0, but since it is not set, so we won't consider this. This is 2 raised to power 1. Okay, 2 raised to power 1 is 2 only. So the bitwise XOR of a and b is 2. Okay, let's try to test, okay, this thing. Let's remove this. Okay, int a is equals to 2 and int b is equals to 3. Okay, let's try to print a is or b. Okay, a is or b. Okay, okay, let's include it within the brackets. Okay, yeah, so one, oh, actually I did a mistake actually. Okay, so let's see where we are wrong. Okay, so let's get back to the screen. So yeah, so okay, I got this. Okay, if it is just opposite of what I told you. Okay, so the bitwise XOR, let's erase all of this. Okay, so yeah, so I got it. So if both the bits are same, then it will give us 0. Okay, and if both the bits are different, it will give us 1. Okay, so 1s or 0 or 0s or 1 gives us 1 only. Okay, now if we try to find bitwise XOR, so a has binary representation as 1 0, b has, which is 3, has binary representation 1 1. Okay, now a XOR b gives us the value in the ones place. 0 and 1, they are not set. Okay, sorry, they are different, right? 0 XOR 1, it gives us sorry, okay, let me erase this. Okay, it gives us 1. Okay, it gives us 1, and in the tens place both the bits are same, right? 1s or 1, okay, so it gives us 0. Okay, so this, let's extract the number out of it. So 0 1, this is the binary representation, right? So the number will be, this first place represents 2 raised to power 0, right? And since this is not set, okay, second tens place is not set, so we won't consider this. So 2 raised to power 0 is going to be 1. Okay, therefore the result of A is or B was 1. Okay, so I got a little bit confused in that, so don't mind. Okay, so yeah, this is how we are getting the bitwise XOR as 1. Okay, now let's look at some more examples on bitwise XOR. Okay, so let me add a new page. Yeah, so let's take some more examples. So let's say we have A is equals to 3 and we have B is equals to 5. Okay, so the binary representation of 3 is 101. No, I got it wrong. Okay, so the binary representation is something like this. Okay, 1 1. Okay, and the binary representation of 5, the binary representation of 5 is uh, 101, right? Because this is 2 raised to power 0, this we won't consider this, and we will consider this as well. So 2 raised to power 2, this would have been 2 raised to power 1, but since it is not set, so we won't consider this. So 2 raised to power 2 plus 2 raised to power 0, this gives us 4 plus 1, this gives us 5. Okay, so yeah, we are absolutely correct here. Okay, so yeah, these are the binary representation of these two numbers. So if we try to find bitwise XOR, what we do is that here in binary representation we have only two places, here we have three places in the binary representation. So what we do in the 3's binary representation, we change it a little bit. What we do is that we add a 0 in front of it. Okay, earlier it was 1 0, we add a 0 because this bit was not set. Okay, and since we have to consider the third bit as well, because of 5 we will take this bit as 0 in the third in the 3's binary representation. Now if we try to find the bitwise XOR, okay, 0 1. Okay, if we try to, this was a binary representation of A, this was the binary representation of B. If we try to find A XOR B, okay, what do we get? 1 XOR 0 gives us 1, because both the bits are different, right? So this is 0, this is 1, so 0 XOR 1 according to the rule. Okay, uh, according to the rule, 0 XOR 1 would give us 1, 1 XOR 0 would also give us 1, and rest of the cases will give us 0. Okay, so 0 XOR 1 will give us 1 only. Okay, 1 XOR 0 in the tens place, 1 and 0 are there, so 1 XOR 0 would give us again 1. Okay, and in the third place, 0 XOR 1, again we have two dissimilar bits. Okay, so again we'll get us 1. Okay, so we get this binary representation. Now let's extract the number out of it. So 1 1 1 is the binary representation that we receive after doing XOR of A and B. Okay, so this would represent 2 raised to power 0, and since it is set, so we'll consider this value. This is also set and this is also set. So 2 raised to power, this will represent 2 raised to power 1, and this will represent 2 raised to power 2. Okay, upon adding all of this, we get 2 raised to power 2 plus 2 raised to power 0, sorry, 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0. Okay, so we get 2 raised to power 2, that is 4, plus 2 raised to power 1, that is 2, plus 2 raised to power 0, which is 1 only. Okay, so 4 5 6 and 7. So we get 7 as the bitwise XOR of A and B when the value of A is 3 and the value of B is 5. Let's test this. Okay, let's get back to the Visual Studio Code. Let's take the value of A as 5, sorry, 3, and the value of B as 5. Okay, let's find the bitwise XOR. Yeah, so the value that we got is 6. Okay, so the value that we got is 6 actually, and not 7. So again we did a mistake here. Okay, so what is the mistake? Let's try to find out. Okay, so in bitwise XOR, okay, one thing that we forgot is that upon doing bitwise XOR, right, here we have 2 raised to power 4, this is 2 raised to power 2, right, which is 4, this is 2 raised to power 1, which is 2, and this is 2 raised to power okay, so we did something wrong here. 3 is represented by, okay, I got it. What is the mistake actually? The mistake is here. We did something wrong with the binary representation, right? So this would have been 1. Okay. Now, if you try to find, the binary representation, the A's or B, it would be 0 in the first place, because these two are similar, okay, similar bits, 1 XOR 1, so it will give us 0. Okay, so let me erase all of this. Okay, so the binary representation that we get is 110. Okay, now in the first place the bit is not set. Okay, so we won't consider this. In the second place we'll consider this because it is set. In the third place also the bit is set, so we'll consider this. So it becomes 2 raised to power 2 plus 2 raised to power 1. So 2 raised to power 2 is 4 plus 2 raised to power 1 is 2. Okay, so it becomes 6. Okay, this is how we get 6 in the output. Okay, so yeah, again I did a mistake, I'm sorry for that. Okay, let's try to run this code. Okay, yeah, so output is 6. Okay, this is how we get bitwise XOR of A and B. Okay, now let me take you to the screen again. Okay, so yeah, these were the main bitwise operators. We have two more operators. Okay, one is the left shift operator, left shift operator. Okay, operator. Another one is the right shift operator, right shift operator. Okay, so let me add some new pages. Okay, so yeah, now bitwise, let's not write bitwise. So okay, left shift. Okay, left shift, bitwise left shift operator. Okay, so this is represented by this sign. Okay, now do not get confused. This is used while writing C out, like this. No, so this bitwise is different. Okay, it is used with numbers. Okay, so how do we work with this? So let's say we have a number int a is equals to 1. Okay, so 1 can be represented in binary form as 1. Okay, rest of all will be 0, but we don't write this. Okay, let's take another example. Int a is equals to, let's say we have 3. Okay, now we can write it in bitwise form as 1 1. Okay, this way, because this represents 2 raised to power 0 and this represents 2 raised to power 1. So 2 raised to power 1 plus 2 raised to power 0 gives us 2 plus 1, which is 3. Okay, so yeah, we can write it this way. Now if we try to left shift a, okay, we'll write this by 1. Okay, if we try to left shift a by 1, okay, we'll write it this way. Okay, a left shift 1. Okay, upon printing this, what do we get? If we try to print this, okay, what do we get? So a left shift 1, how do we find the left shift? So the binary representation of a was this, right? So 1 1 was the binary representation of a. Now if we try to left shift it by 1, this is the binary representation. Okay, and this is the actual number. So if we try to left shift this by one place, so what happens is this bits get shifted. Okay, this a 0 gets added here and these two get shifted, so it becomes 1 1 0. Okay, so let's extract the number out of it. So the number is, this would have been 2 raised to power 0, but since it is not set, so we won't consider this. This is 2 raised to power 1. Okay, and this is 2 raised to power 2. Okay, so 2 raised to power 2 gives us 4. This is 2, and this we won't consider this because this is not set. Okay, so 4 plus 2 gives us 6. So we get 6 if we try to left shift 3 by 1. Okay, let's check. We can also write left shift by as this way. Let's suppose we have a number x and we are trying to left shift it by y, then we can also write it as x into 2 raised to power y. Let's see in this example. So we had a number x as 3. Okay, 3, we are trying to left shift it by 1. Okay, so 2 raised to power 1, left shift it by y, right? So we can write it this way. Okay, so 3 into 2 raised to power 1 will be 6. So this is how we get the bitwise left shift as 6. Okay, now let me take you to the screen and let's see whether we are correct or not. Okay, let's try to write the code. Okay, so let's say we have a number int a. Okay, 3. Okay, we are trying to left shift it by 1. Okay, let's see what do we get. So upon executing this, we get the output 6. Okay, so we are absolutely correct here. Let's try to do this for another value of y. Let's say we take 3, value of y is 3. So we are trying to left shift a by 3. Okay, three places. So we get 24 as the output. So this is the formula for finding the left shift. Okay, so suppose you are trying to find, let me take you to another page. Okay, so you are trying to find the left shift of a number x when it is shifted to the left by y places. Okay, x left shift y can also be written as x into 2 raised to power y. So let's suppose 3, we according to our example in Visual Studio Code, we tried to shift 3 by 3 places, right? The value of a is 3 and we tried to left shift it by 3. Okay, so what do we get? 3. Okay, left shift 3. Okay, so how we can write this? We can write this as 3 into 2 raised to power 3. Okay, so 3 into 2 raised to power 3 will be 8. So 8 into 3 is 24. So this is how we get the output as 24 here. Okay, yeah. So now let's talk about bitwise right shift. Okay, right shift operator. So what happens in right shift is that let's suppose we have bitwise, binary representation of a number as this. Okay, if we try to right shift it by 1, then this right shift can also be written this way. So let's suppose this is a number x, this is the binary representation of a number x, and if we try to right shift it by y, we can write it this way: x divided by 2 raised to power y. Okay, this is the formula to find the right shift easily without working with this bitwise binary representation. Let me tell you how the right shift happens. Okay, so let's suppose this is the binary representation. This is what number it is. Okay, so this is 2 raised to power 0 and this is 2 raised to power 2. Okay, so the number is 2 raised to power 2 plus 2 raised to power 0, which is 5. Okay, so the 5 is the number. Okay, now if we try to right shift 5 by 1, what do we get? Okay, so 101, what happens is if we right shift the value with which we right shift, we remove those values. Okay, so first one's digit value will be removed. Okay, so it becomes 10 only. Okay, so right shift of 5 by 1 gives us this binary representation, and the number would be this, we won't consider because not set, and this is 2 raised to power 1, so it gives us 2 only as the number. So the right shift of 5, if we right shift it by 1, we get the output as 2. Okay, let's see through the formula. Okay, so the formula was x divided by 2 raised to power y if we right shift a number x by y. Okay, so now let's try to find out. So x would be 5. Okay, we try to right shift it by y is 1. Okay, so 5 divided by 2 in the integer division. Okay, if we divide it mathematically, it gives 2.5. Okay, but in the integer division it takes only 2 when we divide it in the C++, right? So 2 will be the output, and we also got the output as 2. So this was all about the left shift and right shift operators. I hope you'd like the video. That's it for the video. Hope to meet you in the next video.